Now this is a non-traditional subject, and I hope you'll enjoy this journey. The next slide will hopefully explain a lot of what I'm talking about here. I found this little guy in a collectible store in Tokyo, Japan recently, and it triggered a very deep and meaningful thought experiment in my mind. So for those of you not familiar, this is the Toy Story alien, first introduced in the Disney Pixar movie Toy Story in 1995. There are a few 3D connections here. Apart from him wearing 3D glasses, we know it's 3D glasses because they're red-cyan. This is the iconic comic view of what 3D glasses are. Toy Story was also re-released in 3D by Pixar in 2009, and also released on the Blu-ray 3D format in 2011. The stereoscopic supervisors, the amazing Bob Whitehill. So of course, when I say can aliens see in 3D, I'm really meaning can the Toy Story aliens see in 3D if they're wearing these pair of 3D glasses. Now there's a lot of very esteemed vision scientists in the room, so I'm hoping that we'll be able to come up with some definitive answers here today. And those of you who've familiar with my work will also know that I've done a lot of work in anaglyph imaging. So this little guy here was actually quite interesting to me because it's really quite sort of an interesting thought. So I've got three main papers on the topic of anaglyph imaging. I've also got a tie, an anaglyph tie as well, if you hadn't noticed. And a lot of them have been particularly looking at, and I'm getting serious here now, analysing and simulating the crosstalk that's present in anaglyph imaging and whether that can be improved and what type of options there are for improving anaglyph imaging, because usually it doesn't perform very well, but there's actually a few reasons why it doesn't and why it could be improved. In those papers, I came up with a simulation model to work out the amount of crosstalk that's present in anaglyph imaging. So we've got a display, and the left and the right eye channels have different spectrums. These little graphs here have frequency or wavelength on the horizontal axis and amplitude or transmission percentage in the vertical axis. And so the red eye has got most of its output, the left eye, which is red, has most of its output in the red part of the spectrum, and the cyan eye has most of its output in the blue and the green part of the spectrum. And so the light comes from the display through the anaglyph glasses, and we have a program that simulates how much of the intended light gets through, how much comes through as crosstalk, and then we can come up with these little diagrams here which show how much each eye would receive for different types of 3D glasses, whether it's red, cyan, or just different manufacturers and different formulations of the filters that are used. So here's just a quick simulation a quick example of some of the results we've got in these papers. We've probably sampled close to 100 different types of anaglyph glasses, both red, cyan, but also other types as well. And here's just some of them here, quite similar results here, tailing off at about 600 nanometers. And the cyan eye, some of them are really got good performance, and there's a lot of variation here. And these ones here trailing off at about, about 560 nanometers. So that's for red cyan. And well, actually let's take a little step back. Anaglyph glasses have been used in a range of other unusual applications as well. So here's a pair of anaglyph glasses being used on a praying mantis or a stick insect. This is the work that was led by Jenny Reed at Newcastle University. She was a keynote presenter at the Stereoscopic Displays and Applications Conference in 2015. And they superglued coloured filters to the eyes of praying mantis to study their insect stereoscopic vision. Now, in this particular instance, they used green-blue or green-purple because they found for the particular sensitivity of the eyes of praying mantis, it was better to use a different combination of colours. They've also been used with cuttlefish. Trevor Wardle from University of Minnesota used anaglyph glasses on cuttlefish to examine the strike at prey behaviour of cuttlefish and their stereoscopic vision in that regard as well. So there's a lot of work in which anaglyph glasses in this instance allow us to understand. All right, so let's jump off from this particular knowledge and go in this little bit deeper, and let's look at our Toy Story alien here with his anaglyph glasses. And the fundamental problem you can probably realise here is that the left eye and the right eye have the same filter and therefore going to be receiving the same eye view. So if we make some assumptions here and assume each of their three eyes receives a different perspective, they're going to be receiving left, right, left views, and I think this would be very confusing to them. So I've come up with a solution, and I think we need to do this. So red, green and blue for each of the three channels of their glasses. Now, of course, people wouldn't recognise this as a 3D glasses, so they didn't do this in the collectible item. But once these aliens actually come to visit Earth, we'll have to have these kinds of glasses available to them. So if we can look at the spectral performance of different types of anaglyph filters again, or anaglyph glasses, so we can have a blue filter over one eye, a green filter over the centre eye. We've got to come up with some new terminology too now, don't we? And also the red filter over the, and this case, I think it was his right eye we were using, but it could be the reverse, of course. So if we combine those together, you can see that if we break up the spectrum red, green, blue, using our traditional red, green, blue displays, we could come up with three channels, which then enable the three eyes of the alien to receive a different eye view. And yeah, so it could work as long as we've recorded appropriately configured footage with a three-eyed camera, but this is a whole new industry we'd have to invent as well. So let's look at polarised glasses and whether that would be possible. We'd want to provide them with a full colour view, and if we could do polarised 3D glasses, that would allow a full colour view. So let's look at linear polarisation, and for 3D purposes, IMAX uses usually vertical and horizontal. Other previous 3D techniques used plus or minus 45 degrees, but there's only two states of linear polarisation. There's no third state, so I don't think we could actually use linear polarisation for a three-channel pair of polarised 3D glasses. Circular polarisation also only has two states, clockwise and anti-clockwise, and that's the kind of 3D polarisation used in real 3D systems. So unfortunately, our little alien here I think is out of luck here and would not be able to use polarised 3D glasses for watching any 3D content. All right, what about active 3D glasses? And here I've mocked up a set of Volfoni 3D glasses, active 3D, liquid crystal shutter. And so normal active 3D glasses switch the lenses, the liquid crystal cells, on and off in sequence with the left and right images being displayed on the screen. So in the case of our three-eyed alien here, I believe it is possible that we could have a sequence of three images and the glasses are switching on and off in sequence with those three images. Now there is a little bit of something we'd need to work out here. We'd also need to know their critical fusion frequency so that we know how fast to switch the glasses so that they don't perceive flicker, but I think we'll need to perform some experiments here, some user studies. I'd also like to think how and whether there is any examples of three-eye vision here on Earth. And there are some examples, but they're a little bit perhaps unusual. In mythology, it is very common to depict a third eye vision, but this really is just symbolic, and this particular aspect is. But there actually are some examples with animals of her having a third eye. Now, in this case, it's known as a parietal eye, and it's only found in some types of lizards, sharks, etc. But it's really just a photosensitive spot. It's not actually an eyeball, so not quite the same thing in this instant. So that little spot just there, I think it is, between the eyes there is the photosensitive spot in this particular frog. But let's think about maybe the compound eye, perhaps. Is that a suitable analogy? The compound eye is a visual organ found in arthropods, such as insects and crustaceans. It may consist of thousands of lenses, which are tiny independent photoreception units that consist of a cornea lens and photoreceptor cells, which distinguish brightness and colour. Now, it's obviously different to our eyeballs, and as far as I can tell, they always just have two, so, but not three, so it's not quite the same. And I'm not aware of anyone trying anaglyph glasses on these little beasties yet. Spider eyes. So about 99% of spiders have 8 eyes, and some have 6, some have 2, some have 4 and some have 2. So spiders got 2 types of eyes. Large pair of primary eyes form images, and the secondary eyes help the spider track movement and gauge distance. But none of these have 3 eyeballs like in the Toy Story alien. So again, not a sufficient example. So in that regard, the Toy Story aliens seem to be unique, even though they're fictitious. Now we also need to perhaps establish some new terminology. So stereoscopy or stereoscopic terms are derived from the Greek stereos for firm or solid, and stereo or scopio for to look and see. So these terms are actually still applicable. So we can refer to the aliens having stereoscopic vision. But obviously the term binocular, the term bi refers to 2. The term comes from Latin, binoculus. So in this case, we'd have to create a new term, which is trinocular, or trinocular vision. All right, so in conclusion, I hope, and perhaps we need to have a show of hands, that I hope we can all agree that the Toy Story aliens could actually see in 3D. And if we had special 3-channel movies, they could probably watch 3D movies. But only if we gave them special 3-channel anaglyph 3D glasses or 3-channel active glasses, but unfortunately 3-channel polarised 3D glasses are not possible. Yeah, I heard the disappointment in the room. Or we could just give them an eye patch, perhaps. All right, well, thank you very much. Appreciate your time.